All right, welcome back. In the last video, we were talking about and constructing a 95% confidence interval for something that's already given to us, right? The statistical test, the hypothesis test was already done for us ahead of time. That's great. And we just wanted to calculate a 95% confidence interval for this proportion based on, all this information that was given to us. But the typical scenario is that you do a hypothesis test, find evidence against the null hypothesis, whatever that may be, and then based on that new sample that you got, based on whatever summary statistic you're testing, that's when you would go and make a 95% confidence interval to figure out the actual, true population, or close to the true population, okay? So in this previous example, we've already done this, right? We did a hypothesis test on this scenario, right? So 38% of the birds in northeastern Wyoming were brown thrashers in 2005. The hypothesis was that it's not that anymore. It is no longer 38%. We went out and calculated or sampled and found data and found that the proportion actually may be closer to 34%. We did a hypothesis test and found that there was enough evidence against there being then it actually being 38% and it being maybe closer to this. Okay, but now our job is to actually figure out what are all of the possible values that the true population could be. Okay, as far as this proportion goes. Okay, so let's do it. Let's do it. Same thing as always. Same thing as always. And let me write out. Let me write out the standard error formula. So it's p hat times 1 minus p hat divided by n. This is all underneath the square root operator. Very cool. Very cool. One thing I think that's a little inconsistent, I think the sample size was different in this one than it was in the last. But that's okay. I mean, whatever. It's not that big of a deal. We'll just say that it's a new. This is what it was always supposed to be. No biggie. Okay, so let's do it. Let's calculate. Let's at least plug and chug some of these values in. Okay. So our sample proportion was 34%, and then 1 minus 34% divided by 1,000, all underneath the square root. Very cool. And it turns out that that is 0.0149, so 0.15 we'll say. Is that the same as the last one? Yeah, it is. How about that? That's pretty cool. Neat. All right. Let me actually just double check. I'm pretty sure that's right. I've got my computer up and over. Yeah, we're good. We're good. Cool. Okay, so that's the standard error is 0.015 again. And then all we need to do is find that 95% confidence interval. So let's recall. We can do it one at a time too. I kind of like doing it one at a time. Each little component here, because at the end it makes it all nice and organized. But let's find the 95% CI. That's what we're looking for. So our confidence level is 95, right? 0.95. So we'll find the lower bound first. So that's going to be our sample proportion minus 1.96. Looking for a 95% confidence interval. That's that Z critical value. No biggie. And then 0.015. Very cool. Turns out that that is 0.31. 0.31. Easy peasy. Highlight that so we don't lose track of it. Let's do it again for the upper. Boop. Okay, 0.34 plus 1. Good Lord. 1.96 times 0.15, right? So this is all the same. We're just changing the sign here for the lower and the upper bound. Very, very easy. Very cool. And it turns out that this one is, all right, 0.369. We'll round that up to 0.37, I guess. Okay. Very cool. Very cool. So let me crank out another blank page here. So our 95, let me zoom it in. .95% confidence interval is, hello? 0.31, 0.37. Okay. Write it like this, 0.31 to 0.37. So we'll write it like this. We are 95% confident that the true population proportion, I'll just call it P, of brown thrashers is between, sorry, we have to be very specific with this, of brown thrashers in northeastern Wyoming. Good Lord, I'm having an aneurysm here. We are 95% confident that the true population proportion of brown thrashers in northeastern Wyoming is between 31% and 37%, right? So this is, again, check it out, lower. 38% is not in that range, right? 34 is, right? We found 34. We do not have evidence that 38% is actually in there at all, right? At least 95% of the time. That's what we're okay with, right? So this is more or less sort of the interpretation. But with this, we kind of see a few things that are neat about confidence intervals. We see that our null hypothesis, our null proportion here, is not in the interval, right? It is not. But what is our proportion that we went out and found, right? Right, 34 is in between here, right? Kind of in the middle too, which is nice, which is great, super great. So that leads us to a couple of principles about confidence intervals that are super, super important. So more generally, we already kind of see it, but a value that is not in the confidence interval can be rejected, right? It's not going to be, there's not a very good chance it's going to be in there, right? Especially if it's way far outside of the interval. What the interval tells us, though, is all of the possible values that the population could be. So a value in the confidence interval, I'll say that very fast, is an acceptable possibility for the population proportion. Now, we're not saying that it's smack dab in the middle, right? But we're saying that it is possible, since we don't really know what the population really, really looks like, right? It's going to be somewhere, it's going to be any one of those values. There's a good chance it'll be any one of those values, okay? Principle 2 here, sorry, I got to click some buttons here on my computer. Give me 1 second. Sorry. Principle 2 is, this is a little bit beyond what we've been doing, but same kind of idea. If a confidence interval for a difference of two proportions or two samples, whatever it may be, does not cover zero. So, for instance, we can't have negative proportions. But if we were looking at the difference between two things, we found that the confidence interval was 4 to 8, the difference, whatever. All of the possible values for the population difference could be in here, does not cover zero. It's reasonable to conclude that the two things that we are measuring are statistically significantly different. And we see that with the p-value, usually, pretty much always, being less than alpha, right? We'll get to that when we do t-tests next week, okay? So no biggie there. No biggie, just a guiding principle. And then the last one, very much tied to this one here. But when confidence intervals for proportions in two different populations don't overlap, it's reasonable to conclude that the two proportions are statistically significantly different, right? Same deal here, right? Just a slightly different sort of context, okay? So we'll get more experience with these principles too, I promise, when we get out of proportions and into testing differences between means, that kind of thing. But for now, just hold on to those, put those in the back of your mind, and And I think that's it for this. So I will see you next time.